Referential integrity is a specific type of constraint for the database. Some of the other constraints that you might be familiar with are, for an example, a data type constraint. A data type constraint says that for a particular attribute, the data has to be a certain type. So we might take, for an example, a student's last name has to be of the type character. We don't want numbers or special symbols in that particular piece of data, so we might put a constraint on the database that says it can only be characters. Another type of constraint is an attribute value constraint. An example of this would be for the month of the year, we would only use values between 1 and 12. So negative values would not be allowed under that constraint, nor would you be able to use values greater than 12. So we would put that constraint on the database, and that would make sure that all of the records for that particular attribute have a number between 1 and 12 or a valid month involved. Another type of constraint that we use is called a key constraint. A key constraint is a rule that specifies the uniqueness of a tuple or a record or a row. So for an example, each record in a regular table must have a unique identifying attribute. So we can assign a student number to a student, and when we put that into the table, we know that it's going to be unique. No two students will share a student number, and that satisfies that key constraint or uniqueness constraint for that particular record. We also call this a primary key constraint or a uniqueness constraint. One of the things we can do when we have that particular type of constraint is that we can make sure that we can relate tables one to another properly. And so we call this a foreign key constraint. So in a foreign key constraint, we have a rule that specifies a reference to another table. Let's take the example of a student table, a student grade table, and a class table. So in the student table, we have a unique identifying number that's the student number. No two students have the same number. So in that table, we can have that student number as the key to that table. In the class table, we can have the CRN, or a unique number that identifies that class and section. In that class and section, we can have all kinds of other data. We might have the name of the class, we might have who the professor is, lots of other data about the class. But that one unique specific number applies only to that class, and every class has a unique number. So when we combine those two, we might say, well, for a specific class and a specific student, what was their grade? So we can have the student grade table, and the student grade table only needs to refer to the student table and the class table, and the only really piece of data that's unique to that particular set of data is the grade. So when we put the student number in the student grade table, we consider that to be a foreign key. The student number refers back to the student table, and the class CRN number refers back to the class table. And this sets up a foreign key in the student grade table. In this example, the foreign key is the same as the primary key, and that may or may not be the case. You can have a foreign key that doesn't have anything to do with the primary key of a table. But in this case, we have the student grade table, and both the student number and the class CRN are the primary key for this particular table. So the grade table references the class table by using the CRN as a foreign key. And the grade table references the student table by using the student number as a foreign key. So you have to be sure that you remember that the foreign key is in the student grade table. Actually in the student table there is no foreign key. In the class table there is no foreign key. There's just a primary key to that table. And by referencing it from another table, the other table contains what we consider to be the foreign key, because it's the key to a secondary or foreign table. If you run a query and you know the primary key to a secondary table, you can easily retrieve data from that secondary table. For example, if you have a student grade record, you can easily determine the student last name. If you have this class CRN, you can easily determine the class name. So those constraints in the student grade table refer to the table's student and class as a foreign key. When you use foreign keys, you could run into potential problems. So what if, for example, a student earns a grade in a class and then drops out of school and his student record is removed from the student table? Or what if a grade is recorded and the class gets canceled? Or what if someone tries to add a grade record but leaves the student number blank? All of these things are potential problems when you have references like this. So what we do is we put a constraint on the table that says you can't do those things. It's usually necessary to create a rule to address those and other potential problems that could arise from missing data or missing records. And that constraint is called referential integrity. To make sure that the secondary record is always in the secondary table, a constraint can be added to the relationship to enforce referential integrity. And that way, if we find a grade record, we know that there's always a student number in the student table and there's always a class number in the class table. So with referential integrity enforced at the database level, the database will return some type of error if someone tries to, as an example, enter a student grade without a student number. The database simply won't accept the transaction, and therefore the tables will be intact and referential integrity will be intact. So in this particular example, a student must exist in the student table for the grade to be added, and a CRN must exist for a grade to be added. And there won't ever be records in the student grade table unless there's a corresponding record in the class table and the student table. And that's how referential integrity works.